I want to go through the week 5 data work with you. If you've already done it and you're real comfortable, this is an optional deal. It's just providing another way to learn if you are an audio learner. You go to the Blackboard and you're going to right click to download the data. And sometimes people get so frustrated and feel dumb because they even have trouble downloading the data, but don't feel dumb. It just takes time to get to be good at this. You're going to right click and save it, save the file, and pay attention to where you save the file. Here I save it on my desktop. You see there file name week 5 data set, and it's as a type a save file. It knows it's an SPSS file. If you right clicked and it automatically opened, that's just fine. If you get, as you're trying to save it, this message, do you want to save it or find a program online to open it? Pick save it. The computer can never find SPSS or open it that way. For all programs, click on SPSS. Yours might be Statistics 18 or a newer version. And then you have to be patient because SPSS takes a little time to open. It can take up to a minute. You'll get this screen first, and I tend to not use this screen. I tend to just use the red X in the top right of that box and close that out. And then I go into the SPSS itself. So what I'm going through now is how to open the file if you saved it somewhere. If it automatically came up already opened and it shows you the data, you don't need this step. But if you save it somewhere, like I saved it on my desktop, I'm going to click on File, Open, Data, and then I'll go and get it on my desktop, double click it, and it'll again take up to a minute to open. And then this is what you see. You see columns of data. Across the top is the toolbar, edit, view, data, transform, analyze, etc. Then below that are some icons you can use as shortcuts to get around in SPSS. And then you see the actual data. Here we see gender, and it's coded 0, 1s. We see age category, and then different variables. So this shows you that you are into the data file. And you have two ways to view the data. You can do a data view or a variable view. What it opened and what we just looked at a minute ago was the data view. We were seeing the actual data. If you, on your screen at the bottom left, clicked on variable view in SPSS, you see the insert there where you see variable 1 is gender. It's a numeric variable. That means it has a number associated with it. If it says string, it has words like it would have male and female. Well, SPSS can't analyze string data, so we don't tend to use a lot of string, but some string data is used in SPSS. And then it tells you the actual label is gender. And the only difference between the name and the label is the label can have spaces and it can be something that's a little easier to understand, whereas the name is often kind of a shorthand kind of a deal. And then the values are the coding that was used when the variable was created. And I'll point out to you on the far right where it says nominal, ordinal, etc. Please don't use that. It is not reliable information. Use your head. Your head's reliable. You might wonder about that sometimes, but believe me, your head's reliable. So what we're going to talk about is testing the assumptions. And the assumptions include deciding on the level of the variable. Here, shoppers are the population, and there are two hypotheses. There's a difference in the total satisfaction by gender, and I put in red there that one variable is satisfaction and the other is gender. And then the second hypothesis, the variable is also satisfaction, and then the other variable is age. If you're working with a data file that you're unfamiliar with, you can use something called the utilities. At the top toolbar there, you see utilities, and you scroll down to variables, and you can then see this box appear. It lists all the variables in your data set, and if you click on one, like I clicked on price satisfaction, it tells you how it was coded. And here you can see that it had 5 choices. It's a Likert item, which is bipolar. It goes from strongly negative to strongly positive. And when they use 6 of these Likert items to get a sum variable, then that is at the bottom of that list. It says overall or some satisfaction rather. And what we've been discussing earlier in this semester is whether you consider summed ordinal variables to be at a higher level, and you can, this is your opportunity to be an independent thinker. I love independent thinkers. I'm not looking for you to be mimicking what I say or do. And so this is your opportunity to start to think for yourself and just have rationales for why you think that. Because as you go on, people will ask you, what was your plan and how did you make that determination? And you just have to have a rationale for your reasoning. And so what we're going to do now is talk about the distribution and how we evaluate distributions. And so we're going to go up to the toolbar at the top of SPSS and click on Analyze. And then we're going to scroll down to Descriptive Statistics and over to Frequencies. And then that box pops up, the frequency box. You move the sum satisfaction variable over to the variable column. And then you click on, just to the right of that word, you see Statistics, Charts, and Format. We're going to click on Statistics. And what we see here on the left is the box that appears when you clicked on Statistics, and you select these things: mean, median, mode, skew, kurtosis, min-max, standard error of the mean, standard deviation, variance, and range. Then you click Continue at the bottom of that box, and then you click on the Charts box back on that first screen that we just went through. And this charts box appears. You're going to click on histograms and show normal curve on the histogram. Then you're going to click continue and you're going to click OK. And then you're going to be patient because, again, all of SPSS takes a little time. And in a minute then your output will just pop up on your screen. And we're going to look through some of the output. This first table shows us the sum satisfaction variable statistics. There were 582 people, that's the N, the sample size. We see a mean of 18.68, and then we see a standard deviation of 5.79. Those numbers are really important to us because we can take a standard deviation and add one, and we can take a mean and add one standard deviation and know about 68% of the population. So a mean minus one standard deviation and plus one standard deviation tells us about 68%. The mean minus 2 plus 2 standard deviations tells us about 96. And the mean minus 3 standard deviations plus standard deviations tells us about 99%. And I'll go through that with you in a minute. But let's finish looking at this statistics box output. We're not going to talk much about the standard error of the mean right now. The median is in the middle. Half the numbers are above it and half the numbers are below it. It's like a median in a highway. We expect it to be in the middle. And we're not going to worry too much about the mode. The variance, we're not going to worry too much about. The skew and kurtosis we'll talk about in a few minutes. But we would like the skew and kurtosis to be 1 or less. If they're around 1, that's okay. If they get up into multiple digits, we have problems, and I'll talk about why we have problems in a minute. And then the other thing here to note is that the lowest score, the minimum score, was 6 and the max was 30. That's what actually came from the population. And so let's talk about a normal curve. You've heard about it, you learned about it before, but the important thing to understand with a normal curve is it never looks perfect like this where all the data is in blue below it. But it is powerful because if when we plot the data into a frequency distribution with a histogram, we can tell if it looks to be pretty normally distributed. And if it does, that's when we know that if the mean was 18.68 and we take 18.68 and we subtract the mean and we add the mean, it tells us that 68% of the scores of the population, 68% of the people who were involved, had scores between 12.99 and 24.57. If we take 2 standard deviations, minus and plus, we know about 96% of the population, and then very few people fall into the tails. So it becomes powerful in all kinds of ways. If we wanted to know weight in kids and it was normally distributed, we can tell where the kid falls if they're pretty normal. They use it in insurance to decide, whether you're fairly within the normal population or whether you have higher risks, your scores fall outside of what they consider to be the normal population. So normal curve is valuable in that it tells us if the data plots this way that we can then identify the ability to use a mean and standard deviation to know about the scores of the population beyond the sample that we're studying. This is what a histogram actually looks like. You see there that the blocks of beige go above that normal curve. That black line is just inserted here. It's not important that the scores fall below that or the bars fall below that. The fact that there are quite a few that go above it is no problem to us at all. We don't care about that. It's generally, this looks like a normal distribution, and you have to get used to this, and you'll practice enough that you'll get a handle on what looks normal and what doesn't. Here we see a little more in the left tail than we do the right tail, but this is a normal distribution. We're going to talk again then about skew and kurtosis. Remember, I told you you'd like those to be around 1 or less. Here we have a minus 0.098 skew. And skew then tells us what happens in the tails. A negative skew has an elongated tail at the left, and a positive skew has an elongated tail on the right. It affects our ability to know about the population when we have very much skew, and that's why if it's very skewed, if the number is way above 1, then we aren't able to determine that we have a normal distribution, and it undermines our ability to use parametric statistics, so we might then opt to use non-parametric statistics. Another thing I want you to learn about is how to use the explore function on SPSS. You're going to be looking at 2 variables at a time. What we just did was we ran frequencies on 1 variable. We only looked at satisfaction. And we could throw more variables into the box when we do frequencies, but it only does 1 variable at a time. It produces 1 histogram at a time. Here we're going to look at 2 variables at a time using the explore function. We're going to put the dependent variable over in the bottom there. It says dependent variable. We moved some satisfaction over into that box, and we moved gender into the factor list. Then we're going to click on plots, and we're going to pick power estimation, and we're going to pick histogram. Stem and leaf will already be picked. Then we hit continue and OK. And this output is going to enable us to evaluate homogeneity of variance, which is another assumption of parametric statistics. The output just scrolls one thing above another. I put it here on one slide just for the ease of review. But the first thing we would see in our output after we ran the explore function is this case processing summary of gender. We see that we have 209 males and 373 females. Whenever possible, we would like to have even groups, because what happens now is we know with more confidence what women think about shopping than we do about men, because we had more women. If we have dramatically different numbers in groups, it really undermines our ability to make conclusions, and that's something that I'll help you think about this semester. If you plan a race study, for example, it gets to be really hard because you need fairly even numbers in the race categories, and that can be really challenging and take a long time for a dissertation. Then you're going to scroll down and you're going to see this homogeneity of variance output box. This is the Levine's test, which is the way in which you determine if there's homogeneity of variance, which is an assumption of parametric statistics. And the only thing that matters in this box is you're going to look at some satisfaction, and next to it you're going to look at based on the mean. You're going to look at the Levine's, but you don't need to learn those numbers. All you need to really remember at this point is the sig value, which is not exactly a synonym of p, but for our intent and purposes we're going to use it the same way. We wanted it to be non-significant, and it is. It's greater than 0.05. So that means there is homogeneity of variance. The other thing we do is we asked for this box plot. And the box plot is really very helpful because it's a visual, and a lot of people are visual learners. So here we look at this and we have the scores in the beige, and then the whiskers show the range of scores. And they look pretty good. They're not exactly the same, but it shows us that they look pretty similar. That's telling us that for males and females, there was a fairly similar distribution of scores. Then we're going to repeat the same explore function for the next hypothesis. There's a difference in total satisfaction by age among shoppers. You already evaluated the satisfaction variable using the frequency distribution when you wanted to evaluate the one variable at a time. Now we're going to use the explore function. When you're answering questions on the midterm and as a researcher in general, you have to be consistent. If you decided total satisfaction, which is the sum of the 6 Likert items that are individually, they're ordinal items, the sum of the 6, you could decide it's still ordinal. If you say that for the first hypothesis, then you have to say sum satisfaction is ordinal for this hypothesis. If you say it's ordinal on the first one and here you say it's interval, well then you're going to lose points because you need to be consistent in how you do things. So here I decided it was interval before. I'm going to call it interval. It's the same variable. And now that I've decided it's interval, I'm going to go ahead and test the assumptions. If I decided it was ordinal, that's categorical. I do not need to test assumptions for categorical variables. I'm done. I'm going to have to use a non-parametric statistic. But I'm hoping I can use a parametric statistic, so I'm going to keep going with my testing of assumptions. The first assumption is normality, and the second assumption is homogeneity of variance, and that's why I use this explore function. I move sum satisfaction over, and then I move the age category over. I do the same things I did before in terms of asking for the box plot, or the stem and leaf plot, and the histogram, and the Levine's test. And then I get this output. The first bit of output there are the age categories, and I see, whoa, real different numbers in those categories. That tells me I know a whole lot more about the 35 to 49-year-olds than I know about the other groups at either end, especially the senior citizens. And if this were race categories, I would have a problem. And if race was a main hypothesis in my study, that would really pose challenges for me. Then I scroll down to my homogeneity of variance box. The only number I care about is the top sig, which is 0.524. I wanted it to be over 0.05, and it is. So I do have homogeneity of variance. And a way in which I can confirm it is by looking at the box plots, and they look pretty good. It's not all exactly the same. The medians are slightly different in the middle of those beige boxes, but the whiskers and the beige boxes are fairly similar, which tells me there's homogeneity of variance. So you summarize your evaluation of the assumptions, and you would say satisfaction is either ordinal or you can say it's interval. I'm going to say satisfaction is an interval variable. Gender is nominal. Age is ordinal. Then I talk about the distribution. The satisfaction variable is normally distributed based on the visual examination of a histogram. And we don't talk about normality with nominal or ordinal variables because we don't expect them to be normally distributed, so we don't even say anything there. And then we look at the variance in the box plots, and we talk about homogeneity of variance. And we say that the non-significant Levines and box plots showed homogeneity of satisfaction and gender, and the same of homogeneity of satisfaction and age. And using the assumptions then helps you decide whether you're going to use non-parametric or parametric statistics. If you decided that the variables were categorical, you would immediately stop testing assumptions if all the variables were categorical, and you would just use non-parametric statistics. Or if you decided that the variable was not normally distributed, you could say because it wasn't normally distributed, you decided you would use non-parametric statistics. You would use parametric statistics if the variables were continuous, if only one, if you only have to have one of them that's continuous, if the variable that is continuous is normally distributed, and if you had two variables in a relationship kind of hypothesis, both would have to be continuous in order to use parametric statistics. And we'll talk about that a little bit more, but we'll really solidify that learning later in the semester. Picking the right statistics. Part of what helps you with that is the wording of the hypothesis. So if a hypothesis says difference, and you decided that the dependent variable failed the assumptions of normality and homogeneity variance, you would then pick a non-parametric test, and a non-parametric test that looks at a difference in two groups is a Mann-Whitney U. If the hypothesis is there's a difference in two groups, like the gender hypothesis, and they pass the assumptions for parametric testing right next to that, then we would use a t-test. So there are in statistics decisions that you make, and there are tests that are comparable. So a Mann-Whitney U is basically a non-parametric test to test a difference in two groups, and a t-test is a parametric test to test a difference in two groups. If there is a difference in three or more groups, as we have with the age and shoppers satisfaction, if they fail the assumptions, we would use a Kruskal-Wallis, and if they pass the assumptions, we would use ANOVA. And if we have a hypothesis there's a relationship between two variables and they failed the assumptions, we would use a Spearman's rho non-parametric statistic, and if they pass the assumptions, we would use a Pearson's correlation. So I would decide to use parametric statistics because I perceive this sum satisfaction variable to be interval level. Can't be ratio because it had no possible zero. It did pass the assumption of normal distribution, and there was homogeneity of variance. So I have decided to use parametric tests, and since the first hypothesis says there is a difference in total satisfaction by gender, gender has two categories, so it's two groups, so I would pick a t-test. And there's a difference in total satisfaction by age. If I have a hypothesis involving three or more groups, then I use ANOVA for a parametric test. We'll talk more about what tests to use this semester, but some of the tests that we talk about, while you're starting to learn them this semester, you won't actually learn to do them until next semester. So the next thing we do is we look at this hypothesis. There's no relationship between the distance of stores from home. Okay, that's stated as a null hypothesis. There's no relationship. And I want to know about the variable of distance from home. And again, I could either go up to the utilities and look at how it's coded, or I could go to the variable labels that are in the variable view of SPSS. Remember, down in the bottom left you have data view and variable view. You could click on it and go find this distance from home variable and see how it was coded. The utilities is a little faster way to get there. But what I want you to notice here is that there are uneven categories. One category has less than a mile, another one has 20 miles, the other one has more than 30. They are unequal categories, so there is only one answer, and it would be ordinal. It would be wrong to say it was any other level variable. Then we go on and we interpret the homogeneity variance. So we did the explore function. We moved sum satisfaction over and distance from home over. We asked for the same things we did before. Then we look at the ends for each of the groups, and we see some issues there. We look at the homogeneity of variance, and we say that there is homogeneity of variance because we have a non-significant Levene's test. We look at the box plots. They look pretty good. I would want you to use the t-test output. And if you look down there in the bottom box, independent samples test, you see a t-value of 0.444. Degrees of freedom is 580. And then we have a sig value of 0.657. It is greater than 0.05, so we would say there is no significant relationship here. So we would reject this hypothesis and accept the null. There is a difference in total satisfaction by gender. No, there is not. We accepted the null because there's no significant value here. 0.657 tells us there is not a significant difference. You could probably figure that out in your head. So one of the things I want you to start to realize this semester is sometimes there's an immediate freak out reaction when people look at stats. And I want you to start to realize that you don't need to freak out. You're bright people. You wouldn't be where you are if you weren't. If you look at those two means in the top box, the men had a mean of 18.8 and the women had a mean of 18.6. That's pretty close. And their standard deviations were really close too. That pretty well tells you there's no big difference in how satisfied they are. So you could almost foresee that you were going to get a non-significant difference when you ran the t-test. So start to look at the actual data and realize that you are bright and you can figure this out. Another bit of output, this is the ANOVA, part of the ANOVA output, and I would want you to primarily look at the SIG. So start to realize the SIG p-value 0.471 greater than 0.05 tells you there is no significant difference. And so we would reject this hypothesis and accept the null. There is no significant difference in satisfaction by age. Again, another bit of output. No relationship between distance of stores from home and total satisfaction. We used a Spearman's rho because the distance from home was an ordinal variable. I had to use a non-parametric test. And here you look at the SIG value and you scroll over, and really what you have here is a mirror in the distance from home box. If you scroll down, you see a SIG value for next to some satisfaction, and under the some satisfaction box you see the exact same numbers. It's just sort of a mirror image. Don't know why they do it that way, but they do. So basically it's the 0.467 p-value that you're looking at. That tells us there is nothing significant. And in fact, that's what this hypothesis said. So we accept this hypothesis, which is the null. There is no relationship between the distance of stores from home and total satisfaction.